Okay, does this match the one in the very, very, very back?
Yeah.
Okay, so stating restrictions, what do you know about radicals? Remember that I know I can square root positives. I can square root zeros, but I can't square root negatives, right? That's what I know about radicals. So what do I need x to be in this scenario to make sure it's either positive or 0? X would have to be, and you're going to have to use an inequality symbol. You know your inequalities? You got less than or equal to, greater than or equal to. Did you pick x would have to be anything bigger than 8 or equal to 8 to make sure that it's positive or 0? What if you had something like this? I'm just going to do a second example. I should have maybe done more. What would you write here? To contain this to a positive or to a 0, what would you need x to be? Same thing, it's an inequality. Did you pick that you need x to be less than 5 or equal to 5? Okay, right? Because if you get bigger than 5, like 8, 5 minus 8 is not good anymore. Okay, multiplying, dividing stuff. So if I multiply, if I do a squared, don't try to shortcut things. What does squaring binomials mean? Repeat it twice and FOIL. So first times first, and again we're doing the whole number part, the radical part. First times first is 4 root 25. 4 root 25. Some of you might be at a stage where you're just like root 5 just makes a 5. If you're jumping to that stage, that's fine. Outsides minus 12, radical 10. Insides, same. Last times last, so what's a negative 6? Negative 6, positive 36, radical root 4, which can turn into a 2, or some of you might have just said root 2 is just straight to a 2. Okay, so this is going to go together. So this is 20. So the number, there's a 92 when I put those together, right? Is that okay? 20, and this is 72. And then this can go together because it's the same radical, so it's just collection. So how many root 10s do you have all together? Okay, rationalize the denominator. So when you have fractions, you're not allowed to have radicals in the bottom of it. So this first question would be what I would say is a singlet. There's just a single radical in the bottom. So to get rid of it, I'm going to times by that single radical in the bottom. But in math, if you do something to the bottom, you have to do it to the top. Okay, so the top is going to end up having a distribution on it. So can you get me that distribution? Okay, is that good? Root 42 minus 4 root 30. And then this would be whole number 2, radical 36. Or the people that are just root 6 is just a 6 eventually, right? Okay, so on your test, if you're simplifying, we need to make sure that our radicals are just done. Does 42 divide by 4, 9, 16, any of those special numbers? I don't think so. Can I divide 30 by any of the special numbers? 4, 9, 16? No. So then I'm done. Okay, some other things you might think about are if these coefficients can all be divisible by something. You can simplify that way as well. Okay, so watch for those things on your final answers because there's lots of places where that happens. So this one is a binomial bottom. Okay, so that was the singlet. So what's the difference when we do binomial bottoms? Anybody remember that fancy special word? Conjugate. Yep. So we multiply by its conjugate. It's kind of like that difference of squares, right? When you do a difference of squares. This is a difference of squares, right? It's the same idea. Those are conjugates of each other. So what does a conjugate mean? Write the exact same thing with the opposite sign in the middle. So this had a subtract, so that one has an add. Yep, it was in the library. So when I started writing on. Okay, so on the top here, you know what you're going to have to do? You're going to have to do all 4 parts of that. So can you produce the 4 parts from the top? How did that go? Did we match on the top? Okay, so then these are 2 binomials, which would be a FOIL, but what's the special technique with the conjugates? We don't need to worry about that. You can do that, but they'll make a 0 when they go together. So you can just short it and you can flip it. So root 6 times root 6. So some of you might write root 36 and some of you might write just 6. Do you understand there's always a subtract there, no matter what you're doing? Out front is a 25, radical 25. Okay, there's something on the top that I don't like. When I use the word simplify, there's actually something that I can change. Anybody pick which radical could get changed? Are there any of those numbers divisible by your special 4, 9, 16, 25, 36? That one, right? Okay, so I'm going to go over here to the side. 2 root 18, what can you change 18 into? A square root of 9 and a square root of 2. And then what is the square root of 9? 3. Okay, so I'm okay with this answer. I really don't like having negatives on the bottom, so I would be okay. You would get 100% if you gave me this, but I like negating the top and then having a positive bottom. So there I just changed the signs on everything. Because it's weird having a fraction with a negative bottom, right? Okay, so that conjugate stuff, you can expect singles and you can expect the binomial bottoms. Breaking down. So for this one, you have to have your magic numbers memorized. Your 4, 9, 16, 25. Okay, what is 75 divisible by? 25 times 3 is 75. So that would be 5 root 3. Ooh, 252, that's a big one. What is it divisible by? Everybody find a divider for it out of our numbers? 4? Yes, but I think I can go bigger. Remember? Did you find one? 36, yeah. 36 times 7. So look at this. It is divisible by 4, but look at the 63. 63 can be divided by another magic number. So therefore, I know there's more. So then I try to go more magic number. Minus 6 root 7. So 108, do you have a divider for that? And you're trying to always get the biggest magic number divider. I found 36 again. Anybody else find that? 36 times 3 was that? You know what I started with? I knew that was divisible by 9. But then I was like, oh, that's 12. And then I was like, well, 12 is also divisible by 4, another magic number, so I better try again. Okay, so I turned the root 36 into a 6, but then that 6 can be put with that 4 because they're whole numbers and whole numbers together. Okay, last one. two numbers that multiply to 28. What did I get? 4 times 7 is 28. Okay, so then this isn't simplified yet. What is the next thing I can do? Root 3's with more root 3's. So how many root 3's altogether? I have some root 7's and more root 7's. So I'd like to know how many root 7's do I have all together. Okay, solving equations. So on this first example, I'm going to want to square right away. I'm going to square right away. Okay, so remember what you're doing here. I'm going to write it the long way. You don't need to, but I just want you to remember what you're doing. Squaring is looking like that, right? So what's the whole number front times the whole number front part? 9. What happens when you do this radical times this radical? Cancels. Okay? So that's what I want you to think about. What does the squaring look like in the long way? You still have to do the whole number front, radical, radical. Okay? And the same radicals, always just cancel that radical. I need you to finish this off on your own. You're going to have some distributions, collect x one way, the numbers one way, isolation, algebra stuff. Okay, you should check your answer when you solve equations. So if I plug a 5 in, here's what I would do. 2 times 5 is 10. Now I'm back to 16. Square root of that is 4. 4 times 3 is 12. Now to the other side, if I plug a 5 in, 5 plus 4, 9. Square root 3. 3 times 4, 12. So they're the same. Okay, so this, I'm looking at the radical, and I would like to get it alone. So everything else is detachable, so you can do some algebra moves to detach those things. So the first, you're going to move the 5 over. You're going to get rid of the 2 from the front. Okay, now this is the point where I'm going to square it. Once I have that radical alone on this one, now I'm going to square. Okay, I can check my answer. Quick mental math. Plugging a 10 in there makes 20 subtract 4, 16. The square root 4 times 2 is 8. 8 plus 5. It's good, 13. Okay, this one is very similar algebra. So same algebra moves here. I can do a minus 10 out. And a divide by 4 out. And what do you know at this stage, once you get to here? You should be writing no solution. And the reasoning is because we're implying the positive root. If there's nothing in the front there, it's implying what's the positive root of something. I always get people who forget that, and then they carry forward and they solve, which if you kept going, yeah, you could get a number, but then once you check that number, it wouldn't work. Okay? So that's why it's also just important to make sure you're checking. Okay, and this is the last one. There's a 100% chance. This is on the test. Obviously not these numbers. Okay, so I'm going to algebraically subtract 3 would be my first move. Does this algebraically make sense if it's just x minus 3? Right? I can't put them together. When I do a subtract 3, that's just what I write. So now I'm going to square both sides. Square cancels square root. And here's the big one. What do we do when we square two things? You have to FOIL it, okay? That's where the mistakes happen. People squaring the individual items. You're not squaring individuals, you're squaring that as a group. Okay, so that's a whole FOIL. Do you guys also remember perfect squares, that it doubles and squares to that? Remember all that stuff too? Okay, what do you do with this kind of math? 0. 0, x squared is the boss, so I move everything else. So I'm going to have to minus an x and minus a 3 to make that into a 0. Okay, does this look familiar? Is it one of the factorable strategies you've learned? Okay, it's a simple trinomial, so xx, what multiplies to 6 gets you a 7. Okay, I'm going to check my answer, especially on the one where it gives me double answers. I should be checking. Checking all the time, but this is the one that's for sure. Okay, so this is me plugging a 6 in and then plugging a 1 in. I'm just going to do the math on it. Okay, so once I plugged it in, it looks like 6 worked, and it looks like 1 did not work in there. Therefore, 6 is the only answer to it. Okay, I would say that that page is very similar to the one on your test where you're equation solving. So you'll for sure get one where you have to do this binomial stuff. You'll probably get one where I'm checking to see if you understand there's no answer to it. You'll probably get one where you're going to have to make sure you're changing the coefficient and the radical. Yep, breaking down, you have 2 of those questions, very similar. You're going to have some singlets, you're going to have some binomials. And word problems. There's a few word problems on your test. I didn't go over that. Your word problems are just solving something and then making a connection back to the problem. And you just have to say, well, how does it connect back to the problem? What is it? What am I solving for in the problem? But no different strategies than what you just did there.